for me is how things are going to be made in the future, how manufacturing is going to change, and that is what I'm going to talk about. So we are going to talk about the future of making things. And what do I see in this image? A very nice, colorful images at Autodesk. You know, we use a lot of colorful images. I'm sure a lot of you have attended some of our presentations. We are a software company. We make design software. But what this image really talks about is someone who is leading and someone who is trailing. Okay, so someone who is ahead is getting fresh air, and someone who is behind is getting the stale air or the gases emitted by the person in the front. So I really want to be the one who is ahead. And you know, as a mechanical engineer, what I learned around 22 years back, when I, let's say, passed out of my engineering college, and through the various jobs that I've taken through my career, I came to understand that things are changing at a very, very different pace. But the knowledge that we are imparted in our colleges, in our curriculum, is not exactly keeping up to the industry needs. And that is where I'm going to talk about three trends here specifically that impact, and the trends that we need to be taking note about is innovation, productivity, and process. So we are also going to talk about products, how they are becoming more intelligent, what are some of the things that we need to consider in reskilling ourselves, and also the production methods that are changing and that have changed rather. That are not just changing, they are of course changing every second now, but a lot of change has undergone in terms of what we have learned earlier and what we see in effect in today's factories. And that's where I'm going to talk about what the future of making things is going to look like. A very familiar picture, maybe not for a lot of people around here, but maybe the people of my age and some of the seniors sitting out here in the audience. We, we were very interested in having a computer in front of us on our desk. We installed software that made our work more productive, and that software came in something like a floppy disk. Of course, I believe this is the 1.2-inch floppy disk, and we had different means of deploying a software. But today, if you look at any software company that provides software to make your work more productive, this is something that is definitely gone. We don't even have, this. Of course, if I just look back, this became a CD, CD became a DVD, DVD became Blu-ray, and now we are just talking about the cloud everywhere. We had a lot of speakers talking about the cloud and how cloud can help you deal with your day-to-day needs about computing and making you more productive. And it's this floppy, the first time, let's say, if I talk about the company I work for, Autodesk, the first AutoCAD software was deployed or installed in a floppy disk around 35 years back. And it's almost been 35 years now since we have shipped the first CD of first floppy of AutoCAD. And if I remember correctly, when I came to Pune, I am basically not from Pune, I am Bengali, but I've settled in Pune. I speak Marathi, perhaps better than some of you here. I can probably say that. But what I wanted to essentially mention here was that when I came here in Pune around 22 years back, the first thing I went running to a COEP, which was holding a 15-day course in AutoCAD, okay, or design, because I am a mechanical engineer, and to skill myself for something that the industry needs, okay, to be able to learn a design software. There was a course or a certificate course that was going on in AutoCAD in the COEP, run by a famous professor who heads the mechanical engineering department now. But that was AutoCAD was a very sort of after skill which moved us from a digital drafting from a drafting board to a digital sort of a scenario where I could cut, copy, paste, erase very quickly, which I could not do on a normal drafting board. But today things have moved on. Things have gone much beyond 2D drafting and 3D design. And I see that skills being imparted in institutes, in colleges, are not in tune with what industry, in tune with the pace at which industry is moving. So I want to sort of, before I start, I want to give you a view of what the design world looks today, and what are the possibilities in design. And I'm going to start with this small video. This video in particular, it was not for talking about Autodesk. Okay, of course, we have made it. It talks about the trends in design. Okay, where design has gone from, let's say, when I passed out around 22 years back in mechanical engineering, to what trends we see today, and what are some of the skills that we need to acquire or reskill ourselves, to be at par with the new emerging trends in the market. So what we learn in our colleges may not be necessarily good enough for us to do our jobs in the future. That's what we are talking about, and we are going to talk about specifically 3 areas, as I said: innovation, productivity, and process. So if I look at innovation, let me talk about 3 good examples of innovation in design. So innovation in design can be something like, I have thought of improving something, okay, as far as my design is concerned, and do something better than what was being done with a design earlier. Or I can think of something that did not exist at all. For example, the drone out there, okay, something that we heard being talked about earlier, how a delivery boy might get extinct because of that drone. And again, a B-2 bomber, here again a very marvel of design and engineering, something that was thought of by, let's say, the Americans in this case. But why I am showing it here is because it's a very unique case of innovation. They have thought of innovating into something that was not thought of earlier. So the drone, the bomber, and maybe driverless cars. Now this one example here is of a company that is innovating in the area of driverless cars. Now when we talk of new skills, okay, and new technologies, and when we talk of a technology or means of communication such as a driverless car, and when someone designs a driverless car, there are many companies doing that. We have Google, we have many automotive manufacturers getting into this area. But this one company, which is perhaps you have not heard of till now, a company called Zoom, okay, has totally changed the paradigm of a driverless car. Okay, why? Because when the others tried to design a driverless car, what they did was they took an existing automobile design and tried to modify that. Zoo totally revolutionized and built a driverless car from scratch, okay, and they are now ahead of the entire pack of all the early innovators. Why? The only differentiation was innovation. They saw it differently. They did not see this opportunity as a means to just improvise on something that already existed. Okay, they saw it as an opportunity to create something totally new. Now, why does a driverless car, for example, a small example, need to have rear view mirrors? Many images that we see of driverless cars being shown on the web, everyone has still has a rear view mirror on it. But why does it be needed? That is because you saw that those images, because those designs were essentially done based on something that was already existing, and you had your mind acquainted to a certain way of design. So Zook is something that has innovated. Productivity is again something that is a very temporary, I would say, driver. Okay, everyone can be productive. There are companies who have innovated in productivity. Ford, for example, with their T-series T model of the car, the factories that were designed, the processes that were designed in the Ford factory became benchmarks. But those benchmarks were easily copied by other competitors, and those are no more benchmarks, they are necessities. So means of improving productivity cannot always be said to keep you ahead. It can only keep you ahead for only a small amount of time. And processes. Now processes is something which is highly getting innovated. I would specifically want to mention this shoe by a company called Under Armour. I'm sure we are all aware of Under Armour. We have a store in Pune that sells Under Armour shoes as well. Now what's so unique about this shoe here is that it was, it's a shoe design, it's a shoe that fits someone's leg. But what's so special about this is the sole that was designed keeping in mind a manufacturing process, and which could not be copied by anyone so easily. Okay, so the sole that you see has been completely generated and completely made and designed by a process known as generative design. Okay, it's not something that an individual can do. I cannot do generative design without a software. Okay, so generative design is a skill that I cannot learn and master. I cannot sit on the drawing board or use my conventional tools to do generative design. Generative design is a methodology. It's a software and processing dependent thing. So I need to skill myself in those areas. And this, the change that we are looking at is actually what we claim is once in a generation opportunity. This is perhaps, as we talked about, the fourth industrial revolution, or we say that today the change that is going to happen very fast. And maybe some people predicted a time period of 10 to 20 years for the change to happen. But what we are saying is this change is going to happen very early. These technologies that we are talking about are going to come at our doorsteps in just a matter of few years, a couple of years. I'm talking about 2 years, 3 years is where we are going to see driverless cars, we are going to see other things that I talked about, coming to us. And we are not skilled enough. Our education system, our curriculum is not skilled enough today to adopt some of these technologies. That is where a lot of these learning apps, or the apps that actually provide, I may name a few. For example, Udemy is something that I follow, and I also follow some of the courses that are offered on Udemy. But I really feel courses that are offered on Udemy, for example machine learning, are some things that should be made a standard part of some of the engineering curriculum, which is not there today. Now production is also changing. Okay, now some additional things. We have heard of, I'm sure we have heard of Kickstarter. So today I really don't need to bother about how I gather funds. Okay, I can crowdsource money. I can go to Kickstarter, display my product. The world over, people have access to Kickstarter, and people who like my concept really give me funding. So even acquiring money is something that is not something which is very difficult today. So the production is changing. Things like this design, for example, okay, means the design today, if I were using my conventional tribal engineering knowledge that I learned in school, I could never learn in college. I could never design this product like this. Okay, this is automotive engine product, and we see a structure inside that is not possible to be done or designed using conventional design software and calculations. So there are companies that have adopted this. This is an example from Toyota. In fact, Toyota has designed engine blocks like this, and they have been able to achieve weight reductions in to the tune of almost 60 to 70% over conventional design. Now, this is what I wanted to share today basically with you is, what we can do with one person using a computer and perhaps a set of software is only a limited set of options is what I can produce. Okay, I have one software. There are many good softwares in the market. We are not the only one who make design software. There are other companies who make better software perhaps than us. But I, as an individual with a very powerful computer at my desktop, can only do certain limited things. Okay, but what if I am assisted with the power of cloud? We already heard and saw the power of the cloud. Okay, we had a gentleman talking about how cloud can help us innovate. So today, every technology that is out there, in fact, if it is assisted by supercomputing power, which cannot come from one single desktop, but which can come from the cloud, can allow you to create n number of alternatives. So another thing that I would say where people need to reskill is learning these algorithms, learning things like machine learning, okay, which will help you adopt these newer technologies, which should be made a part of our engineering curriculum. A very good example is sort of shown in this video here.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined. This is generative design, a technology that harnesses massive computing power, creating forms with precise amounts of material only when needed, achieving maximum performance while wasting nothing. But generative design can be about much more than simply turning out alternatives. Prototypes can be scanned and equipped with sensors that provide real-time performance data that can loop back into the design process, so the object, in effect, co-designs itself. And depending on the material and method of manufacture chosen, the software can optimize the design for those choices. In its search for the optimal design, generative design creates complex forms that would otherwise be impossible to make using traditional manufacturing methods. Now, with advancements in material science and the ability of 3D printers to print metal, companies like Airbus can create forms like this airplane partition panel that's half as light and just as strong. The result? Significant reduction in fuel costs and CO2 emissions. The things that have limited us in the past, software, materials, manufacturing, no longer do so. With generative design, the world can look and perform any way we want it to. This is the next stage in the evolution of design, and it's happening now.
So this is a very good example of how design methodologies are evolving. They are purely not based on empirical calculations anymore. They are based on tools which require compute power. And we have a lot of companies, including our lead sponsor here, AWS for example, providing some of those services. And I don't see any curriculum today that incorporates some of these means and technologies in their study material. I don't come across any engineer who, when he passes out of his college, knows anything about machine learning, for example, or things about cloud computing. So this is something which where the industry is moving to, but our courseware, our study material is absolutely not tuned for embracing these things. So this is what I wanted to share today. In fact, I will sort of end my presentation at this slide. And to summarize, what I have been talking about is, I learned things in a certain way. Perhaps engineers today have learned a little more. But even some of the textbooks have remained same, I would say. Most of the authors that I knew are known by people today. Okay, not a lot of things have changed as far as what is being taught is concerned. But as you saw, whatever you saw on the screen, those very nice videos, they are not futuristic. They are things that are happening today. They are things that are being done by innovating companies, and we really need to find out means to incorporate some of this knowledge and information in our courseware in our professional degree colleges. So that's what I would call the future of making things. This is how things are going to be made in the future. Thank you.